Sometimes when we want to take the derivative, we have two functions being divided by one another. When we have this, we can use something called the quotient rule. The definition of this is we want the derivative d over dx of f of x divided by g of x, and this is going to equal the bottom g of x times the derivative of the top f prime of x minus the top f of x minus times the derivative of the bottom g prime of x. And this is all going to be divided by the bottom squared. So to put this in example form, let's say we have some function y is equal to 4x to the third divided by 2x. If we wanted the derivative of this, we'd say y prime is equal to, and using the quotient rule, we could say we want the bottom, which is going to be 2x, times the derivative of the top, which is going to be 12x squared, minus the top, which is 4x to the third, times the derivative of the bottom, which is just going to be 2. And this is all going to be divided by the bottom squared. So if we were to go ahead and simplify this out, we would see that we'd get, that's going to be 24x to the third minus 8x to the third over 4x squared. And this is going to be 16x to the third divided by 4x squared. And if we canceled on the top and bottom, we would be left with 4x. So that is the derivative of our function y. But to keep me honest, I'm going to go ahead and do this using the power rule as well. Let's go ahead and simplify this function. So if I cancel out top and bottom, I'm going to be left with 2x squared. And if I just take the derivative using the power rule, we're going to have y prime is equal to 4x. So we see that my derivative using the power rule and my derivative using the quotient rule are the exact same. So we see up here, this is the definition of the quotient rule.